Ladies and gentlemen, thank you for joining today. This is your host Nino, inviting you to an extra and sort of bonus episode on Apple's Unix AUX. Apple's first serious foray into the world of Unix from towards mid-end 1980s till about the mid-1990s. And while that system is not counted as the direct progenitor of what you nowadays know as Mac OS, that would rather be next step, it seems to still have left its mark within Apple, in particular in terms of procedures and experience in handling a marriage between one's own System 7 GUI in this case and an underlying Unix foundation. That makes the system actually surprisingly pleasant and modern if you try to actually do things with it. It does not stay much in your way, for it offers you the applications of both worlds, both the Macintosh world and the Unix world. As of course customary at the time, one might almost say, and not different in the other major systems of the day, not everything is always completely smooth. Some things work better, some things work a little bit worse, but all in all it is very interesting to experience, and I certainly encourage you to do so, which nowadays, in particular if you own a Macintosh, is surprisingly easy, for there is a prepackaged Qemu virtual machine under the name AUXrunner, available on Mendelssohn.org. And if you get it from there, then basically you don't need to engage in the hassle of installing it, but you just have a nice working system at your fingertips, ready to be subjected to all sorts of experiments. But before we go there, I would like to express my sincere gratitude to Mr. Fahrenheit. I absolutely encourage you, my dear viewers, to check out Mr. Fahrenheit in connection to AUX if you wish to engage in that system. This person has done incredible things to make our life easy, pleasant, and interesting in regards of experiencing that system as it is. For you, if you follow a little bit the things he has created, and which I have mentioned in previous videos, will be quite equipped afterwards with a full and rich system, not just some sort of blank slate that you're not sure what to do with, but something that might give you the feeling of what it might have been like if you had a well-equipped machine with AUX at the time. So that said, I would also like to remind, before we jump into the topic of today, how one can transfer files on AUX, at least how I am doing it. So this blue thing that you see on the upper half of my screen is my terminal on my modern Macintosh, on which I have installed AUXrunner and which is constituting the host operating system. There I have discovered, let's say, a browser for the Macintosh, which is called MacLinks and which you can find on floodgap.com. And if I want to have that system within AUX, then first I am using UU encode in order to turn that archive into something called MacLinks UUE. This is an ASCII file that can easily be transferred over the network, even if there is some other line noise and a little bit of chit-chat before and after the transfer, making the whole thing pleasant and flexible to use. Then I'm cutting out that text file, in essence, to a netcat listener, and in AUXrunner I can simply catch that thing by saying telnet to my host machine, in this case telnet to 10.00.27 on the port of the netcat listener, and simply issuing this out to needed to press enter here simply issuing this out to the local machine. So now it should take it. Once it takes it, it says connection closed by foreign host, and we have transferred the file to the virtual machine. I'm going into more details about that in my first video concerning AUX. Once you have it, you are UU decoding this file, which you just catted out. So I would say UU decode maclinks.uue, and that would be giving me the SID archive. You see it here that I encoded initially. And today we're not really going to focus on the browsing, though briefly I shall it, but rather on the AI languages of the day, being primarily Lisp, Scheme, and Prolog that you see in front of you. And here, before we really jump into things, I would like to show you where I got them from and where you may get AI languages from if you have all sorts of antique systems. For once upon a time, there was a publication with a lot of Lisp, Prolog, and Scheme implementations, and mirrors of it still can be found nowadays. This one is on cs.cmu.edu. But that is actually irrelevant. If you just look for the path of AI util lang something, or impl prolog, you will nearly certainly find mirrors containing these files. And there you are essentially going to feel like a child in a bonbon shop, for you have all sorts of prologs for all sorts of operating systems. And the question is just what will work. The same applies, of course, to Lisp and Scheme. Lisp I have already shown a little bit in a previous video, but still we shall have a brief look at all three here once again. So this is where you see the Prolog listing under the implementations, and it was not entirely easy to find one that works on AUX. For not being a genuinely simple Macintosh system, some of the systems presented on this site in general do not work in AUX. We will meet a few, I will show you what happens. But beware that not everything that is advertised as Macintosh compatible is also compatible with AUX. Some of the applications are commercial, many are free. Look for what might interest you. The one I recommend most of all is Beta Prolog in version V12, which you'll find under this address. Other ones I just would like to give you a little bit of an overview over are, for instance, also Frolic, which was written in Lisp. We will find a lot of prologs which were written in Lisp. I'll not enter into these because the syntax is not entirely what true prologers are so fond of, so your miles may vary, as they say. There is Skilog, embedding of Prolog in Scheme. So you see the Lisps were quite influential. Nowadays, of course, also the reverse exists. There you're even having a Prolog in just one Lisp file. So not multiple files, but this ppcl is giving you just in one common Lisp file way long before Canren and mini Canren that nowadays exists such a facility. So this idea of having the one AI language in terms of the other AI language was well known. Then there is this JB Prolog, which is really good and which I'm very fond of and which does work. One of the ones who do work and which we will have an actual look at. And there is, however, also my favorite one, Trisha. Trisha in version 09B specifically, not in the other version, is going to give you a really modern looking Prolog environment on AUX. And if you had to pick one, that would be the one I would advise you to pick. Now, regarding XLisp, a little embarrassment, one might say. See, in my previous video, I proudly declare that I did manage to personally port XLisp to AUX. I did so, but it was not necessary, for it existed pre-packaged. And you can really fetch from here the HQX file, and then you will not only have XLisp, but you'll have it graphically. So it's maybe even nicer than what I did, but it has a lower recursion limit, a clearly lower one, so you do pay off a little bit something for running it in the Macintosh half of the AUX system rather than in the Unix half. But do be aware it exists also that way. Now, continuing onwards, we are arriving at the schemes, so lang scheme impl, as you can see. And while there are a lot to choose, and quite some also for the Macintosh, be aware that not everything works. This is exactly the murky area sometimes where AUX does not seem to be accepting certain programs that would otherwise work on a Macintosh. And yet others are very much depending on the GNU tools, which are not included in AUX a priori. And it is interesting to see how influential Stallman's C compiler already had been at the time before Linux was a thing. That a lot of such systems, even though you had different Unix systems underneath, were still depending upon the same development toolchain. One very nice system that I can certainly recommend to you is Scheme-in-1 Defun, or the famous Syod, which works rather lovelily if memory serves right. Another interesting thing to note is that we're having one more scheme written in Lisp, Rabbit Lisp. We're having Scheme 88 that we shall be looking into. We're having as an interesting failure Pixie Scheme. Now that's interesting because it is actually a very well-known scheme for the Macintosh, somewhat of a pity. We're having Gambit, even though the file is called differently as interp, like interpreter something. Gambit is a very well-known scheme system, exists even today, and I did have it for a while on iOS on my phone. I just can't seem to find it nowadays in the App Store, but you know, nice continuity. And finally, we shall be having a look at Elk. Well, then on with the show. Let's have a look at AUX itself. So here I am now in the virtual machine, and I propose that we start with something graphical so that we get a little bit of an impression of, you know, what's possible, what can we do, what can we not do, and what do things in general look like. So XLisp, the graphical one, the one I didn't port, the one which you can install with zero hassle, is really just here. It would operate just the same way you would expect, but it has one lovely bonus. If you look at the closing parentheses now and the opening as I press it, did you see? It has completion. So if I have a bunch of opening parentheses and I want to close them, then XLisp is not going to just let me count on my fingers, but will instead signal things to me in a very friendly way. So XLisp works, and I'm very happy about it. I sometimes can't seem to exit it though. As a contrast, and not from that website I showed you, I would like to show you MCL, Macintosh Common Lisp. That was a very well-known Lisp for the Macintosh and allegedly Peter Norvik's favorite environment at the time. But you see it presents here just a bomb. I rather press the left invisible button than the right invisible button so that it terminates civilly. It does leave a bit of a screen artifact behind, but we can clean that by simply dropping the screen and lifting it again. So that shows you not everything which is foreseen for the Macintosh will work here, and in the Lisp Scheme and Prolog area, that seems to be particularly true. I assume because of these pointer operations these systems must be doing in the background. So that is a Lisp which didn't work. Now let's have a look just very briefly at the scheme which doesn't work, which is Pixie Scheme. So if we open here this one, it does actually load and start up nicely, but when you are at the top level, you cannot type out. Try to type as 98. Yeah, here nothing works. That is not true for everything. I can type D's and A's, and I can engage in Dadaism. I think I have a Y too, but yeah, you see a few letters work, by far not all. And that makes it impossible to actually use Pixie Scheme, so I really have to give this up, even though I do encourage you to try out Pixie Scheme on some other old Macintosh. It is a lovely system. Well, that didn't work. How about something that half works? So let's try Gambit, which I mentioned to you already. The Mac Gambit interpreter seems to load nicely and everything looks lovely. And if I now enter an expression and say +3 and 4, It even does have syntax highlighting in terms of parentheses completion, just like XLisp does. But if I press enter, nothing happens. For whatever reason, and I'm making here no mistake, it is just not accepting, me pressing the enter key. It will not work even if I try with Control M or Control J. It just does not get line endings and is inoperable. One might say, why do I still have it? Why would it still be worthy of consideration? Oh, because it seems to work in batch mode. I can open a file just so you see it. I could also straight run it. Here, fact.scm, and show you how a factorial can be computed. So this was from the examples, and I only added in the end a command to display, so to say, print the factorial of 10. And if I now go under special and load fact.scm, we are going to get the factorial of 10. So there you have it. So the system is not operating interactively, which certainly is a bit of a loss, but it's not a complete, complete failure, given that you can actually still perform operations with it in this batch-oriented processing. Well, substellar, I know what you're thinking, but not all is lost. For what does work is SIOD, or Scheme in One Defun. So, visiting it, here we have our application program, and it's funny because it really just looks like some sort of artificially created command line just for the purpose of running SIOD, but there's nothing wrong with that, and it is working just the same way you would expect it to do in, a different situation. So if I say add 1 to 3, I'm getting 4. It's a little bit chatty in terms of space and garbage collection and so on and so forth, but it's perfectly usable. And so if you want to have a no-hassle scheme, certainly SIOD is something to consider. Interesting that it can't exit though. Would it quit? Yes, it does. And then you have to still manually quit it because it is apparently just confined to its little own command line. So that's how you get a scheme. We checked out now the XLisp Lisp. We checked scheme. Now, before we continue onwards to Prolog, I would like to show you one final Lisp that half works, which is a little bit of a pity, for it is called Power Lisp, and it has been apparently created by Roger Corman, whom I greatly respect and who has some fame in terms of creating Lisp systems. And this once again features the same issue that we saw in Pixie Scheme. In other words, even if I type here something, it will just not be accepted. So I can type whatever I want, but the interpreter fails. This is not to say that we can't, again, batch execute something. So if we just want to open a file to have a look at some example, for instance, at primes Lisp, let's have a look at that, right? I have just added down here this one line, which is forcing a print of that function. Okay, so you see what we're going to do now, and now we're going to execute this primes Lisp thing, and we're going to get output. So again, this is working, but only in a batch operating fashion. I don't want to save any changes to the worksheet. It has this worksheet, which is this displaying you the results on and where you could normally interact, but now just cannot. And now let us go onwards to Prolog. Let's start with JB Prolog. Very good. So, open menu. I opened a little philosopher database that I created and that we can now consult, so to say, enter as knowledge into Prolog, and we can ask questions about it. I could ask, is there some known man? And it will tell me Socrates. And if I press the semicolon, it is going to tell me Plato. And if I'm pressing enter, then it's all satisfied. And one could say, this is perfect, right? Almost though. For if I say man Socrates, then it's not saying yes, it's just saying nothing. And it makes this new line, and when I press again enter, it gives me on a separate prompt. And that's the only way I know that it should say yes. For if I say man hedgehog, then it just gives me the prompt. This is the only difference between a Prolog yes and a Prolog no, which it gives to me if I am not asking for the fulfillment of some variable. Hence, I am saying JB Prolog is working reasonably well for most tasks, but not entirely perfectly in all regards. Still completely usable. And the one I do certainly recommend would then be Trisha 9b, which when you unpack it is becoming a UP-mail Prolog. And we can launch that this way, and you will get exactly the way you would normally know a Prolog system, where you work from the command line as if it is deep in the 1970s. And so you can say consult man. no square brackets, Nino. And if I now say man of X, so to say who's a man, Socrates, okay, and I'm saying semicolon Plato, and I'm saying semicolon Aristotle, and I'm saying semicolon Diogenes, and then no. Then if I would ask man bird, then it is going to just give me a no, the way I would want to see it. So this shows that we actually have working Lisp and Scheme and Prolog from the graphical Macintosh environment. And now let us have a look at the Unix command line and see what can be accomplished there with reasonable and not too great adjustment and configuration. For this, I shall be going to my home directory, and I shall be increasing the font somewhat so that you can see me doing anything here at all. Put things here. Okay. And if we go to BP, or BP, not for British Petroleum, but for Beta Prolog in the version 0112, or what it was, or version 112 that I have shown you in the beginning of this video. Then when we look around, I have compiled it already, we see a couple of files and directories, and we actually have to go to the directory library, assuming that it's not yet system-wide installed. And there I have actually created a little startup file that you see right here, prolog.sh, that contains already all the parameters necessary to start this up. And once we run it, we are entering beta Prolog, in which we could consult things or assert things like that there is a man named Socrates. And it would really work just the way you expect. So I can ask, is there a known man? Then it is going to say Socrates, yes. I can ask, is Socrates a man? And it is going to say yes. And if I want to say, I want a man-child, then it is going to say no, for they are all in the Reddit subreddit for Common Lisp. So I can now say halt, and I am out of here. Okay, let's see what other things we are having. And I could now dive into the schemes. I have already shown you in the previous demonstration that we are having an operating GNU Common Lisp, so I shall skip that for now. I am also going to skip the operational XLisp that I have shown you already too, and continue onwards towards the schemes. Then the target is really ELK. ELK is compiled without too great difficulties. And there are just a couple of configurations that I would like to show you that you need to undertake in order to be able to get it running. First, in the directory config that you see here, you have to choose the type of machine that the system is supposed to be configured as. If you look at it, I mean, there is nothing like Apple Unix, right? But it turned out that it was reasonably easy if you pick simply the 386PC System 5 Release 3 CC version. So to say, that is such a poorly equipped Unix that nothing particular is required, and it just simply sort of compiles. You have to copy that or link it to a file known as system. And if we just have a very brief look at system, then you see it is already saying, just as I told you, this is a 386 PC. It is somewhat ironic that a Motorola 68K architecture might resort to such trickery in order to get an easy compilation. Now, back in the main ELK directory, you also will have to adjust the makefile in one very small way, and that is regarding the subdirectories to be included. Do not include anything after xlib. By default, there are a couple of x11 folders which are following, but this then does not compile. I mean, it fails gracefully because you still get something useful, but it's best to just keep xlib as the last line of the subdirectories. So you will have to look for it under user elk bin scheme. And it also looks for certain files in certain directories that you need to create. It will tell you when it fails, you create a directory, you try again until it installs, and then it will work. And then it is just a nice and normal scheme system, the way you would be used to seeing. And thus we have, apart from XLisp and GCL for the Lisps and the Prolog system demonstrated before, now also a scheme system for the command line. And that, ladies and gentlemen, pretty much gives you a good overview over the AI systems. And I would like to now finish with a couple of practical notes for those who wish to embark on this endeavor. When you are getting the HQX files, these are in essence text files. It's a sort of compressed archive ready to be transferred over the internet. Then some of them will be expandable by the Stuffit Expander 4.02 and some by the Stuffit Expander 5.5. You really need both Stuffit expanders. It's a little bit not a hard science. Some archives just seem to strangely resist. Have both. Don't be frustrated if it doesn't work with the one, try with the other. And one final note. BASIC is not commonly called an AI language, yet it was certainly a very well-known language at the end of the 80s and beginning of the 90s, and it is also available in terms of quick BASIC for Apple's AUX system, and it works just fine. So if we run the program, we're getting here the hello in the output window. You can totally use quick BASIC. What you cannot use is Microsoft Basic 2.00. So this is more the equivalent of GWiz Basic that you know on DOS, and that decisively doesn't work. In fact, it misbehaves very badly, and strangely today it didn't, but now it does. I just needed to close the window, and now you see what a blinky show we get, which, however, AUX is finally going to handle, and we're going to return to our normal system in time. And I am very much looking forward to greet you for further adventures. If not a subscriber yet, please consider joining our friendly club. That's it for today. See you hopefully soon. Thank you for joining, and from me, goodbye.